So we're going to do another couple of examples of these from the notes, and I'd like you to open up your notes to page 33. So we're working on page 33 and we have two examples here that we're going to look at today. The first example, we're just asked to solve for x and y, and we have a line and a curve, so let's identify which is which. We'll call this one the line because there is no power in it, and this one is a curve because we have a power of x. And also we've got x multiplied by y. That's the other thing that shows us that we don't have a line. In a line, x and y are never multiplied together, but they might be if we have some kind of curved function. When I call it a curve, I'm talking about the graph of that function will be a curve. Okay, so go through the steps again. The first step is to rewrite x in terms of y. So we'll have x equals something, something, something. So x will be 1 minus 4y. And I'll put that in a box because I'll be referring back to it later. Then the second step is everywhere I have x, I need to replace it with 1 minus 4y. So instead of 2x squared or 3 by something by y, every single place I replace it with exactly the same formula. 1 minus 4y here and 1 minus 4y here, because we know the value of x in terms of y. Then we multiply out all of our brackets. Remember that this is just going to be 3y by 1 minus 4y. So I can multiply the 3 and the y together first and then multiply it through the other brackets. This will be 2 by square the first, 1, square the last, 16y squared, multiply them together, minus 4y, and double that, minus 8y. Depending on the problem that you're doing, you might find it easier to write this in the middle or write it at the end. And it doesn't matter so long as you put the right sign with the right term. Then this will be plus 3y by 1, 3y, plus 3y by minus 4y, minus 12y squared. And I'll bring my minus 35 over at the same time. Multiply out everything. 2 plus 32y squared minus 16y plus 3y minus 12y squared minus 35 equal to 0. And then it's just a case of like terms. Remember that the minus belongs to the number after it. So this simplifies to 32, take 12, 20y squared, minus 16 minus 35 is minus 51y. I'm going to double check that. So minus 16 take 35 gives me minus 51. And then I've got, oh, I should be careful. I put the wrong thing together, didn't I? It's minus 16 plus 3y and not minus 35. Okay, I nearly put the wrong types of terms together there. Okay, minus 16 plus 3 is minus 13. That's easier to do. So we've got a minus 13y here, and then I have a plus 2 and a minus 35, which gives me minus 33 equal to 0. And that doesn't simplify. Okay, there's nothing that divides in. So I can go ahead and I can try using the guide number method, and I might be lucky and there might be factors. But in a case like this, I would always just plug it into the minus b formula. So for my fourth step, I'm going to solve. Y will be minus b, minus a minus 13 is plus 13, plus or minus the square root of b squared minus 4ac all over 2a. And then this part, I'm going to put it into my calculator, including the square root sign, all in one go, and see what it simplifies to. So we have the square root of 13 squared, you can drop the minus if you want there, because when you square it you get the same answer, minus 4 by 20 by a negative 33, and that simplifies to 53. So I would have had factors, but it's not, they wouldn't have been that easy to find. So y is going to be 13 plus or minus 53 over 40. My plus answer and my minus answer. My plus answer will be 13 plus 53 over 40. 33 over 20. And my minus answer, same thing, but come back here and change that plus to a minus, minus 1. So y is minus 1. Now for each of those answers, I need to plug them into my star equation. So when y is equal to 33 over 20, x is going to be 1 minus 4 by 33 over 20. And just let the calculator do the heavy lifting there, okay? You can work it out, 4 goes into 20, you've got 1 minus 33 over 5, and mess around with that. But it's easy to make a mistake with fractions, and there's no extra points going for showing that work. So we're going to have 1 minus 4 by 33 over 20, which gives us minus 28 over 5. Minus 28 over 5. You leave that as a fraction. So my point, one of my points of intersection will be minus 28 over 5, comma, 33 over 20. Or you could write these as decimals. Minus 5.6, comma, 1.65. It's great if you're more comfortable with decimals. It's great when it works out, but unfortunately, they won't always work out. If you have a 3 under the line or a 7 under the line or something like that, so you need to be able to work with the fractions as well. Okay, the second solution then. So either of those will get you full marks. The second solution is when y is minus 1. So then we have x equals 1 minus 4 by minus 1, which is 1 plus 5, 1 plus 4, which is 5. So 1 minus 4 by negative 1, which gives me 5. So that point, the second point of intersection, is the point 5 minus 1. And do make sure to write your x value first, even though the y value is the first one we found, and your y value second. Okay, so you can see the procedure is the same, even if we've got fractions to work with. Now, let's go on to example 4. Same procedure, but this is a little bit like example 1 again. I know it's not going to work out. How do I know that? They've asked me to show that the plane will not pass through a cloud of ash. Let's read the full question. A plane is travelling along a straight line, like this. So here I've got an airplane that's travelling along a straight line like this, and there is a cloud of ash, cloud of volcanic ash, that is described by an ellipse. So an ellipse is kind of an egg shape, a squished circle. So I have my line. Here I have my linear equation, and I have my curve here. And they've asked me to show that they will not intersect. So that means that when you try to solve the quadratic, you will have a negative discriminant, a minus discriminant. The number under the square root sign will be negative, and you can't solve it. So we know that that should happen if we solve this correctly. So let's go through the process. The first step, will be to rewrite the line as x equals y minus 4. That's bringing everything to one side. So I've got x equals y minus 4, and that's my star equation. Then I sub it into my ellipse equation here, my curve. So everywhere I have x, instead I'm going to have y minus 4 plus y squared, bring the 9 over, equal to 0. Square out the brackets, y squared minus 8y plus 16 plus y squared minus 9 equal to 0. Multiply out 9y squared minus 72y plus 16 by 9, calculator job, 144, plus y squared minus 9 equal to 0. And then I'll gather my like terms. 9 plus 1 is 10, 10y squared minus 72y, 144 minus 9 is 135 equal to 0. Now I don't need to solve this because I'm already expecting that it's not going to have solutions. So all I have to do is examine the discriminant. A is 10, B is minus 72, and C is 135. Sorry, that went off the screen. So my discriminant my b squared minus 4ac is going to be minus 72 squared minus 4 by 10 by 135, and I get, just plug that into our calculator in one go, minus 72 squared minus 4 by 10 by 135. And it is a negative number, minus 216. So this is a negative discriminant, which means complex solutions, imaginary solutions, or no real solutions. So therefore, the plane never intersects. There's no points of intersection. The plane never intersects the ash cloud. And there's our conclusion. And you would need to write this down for your conclusion as well to get full marks in a question like this. Okay, so hopefully that makes sense. Just like example 1 as well, when we tried to solve the quadratic, we got a minus under the square root sign. We couldn't solve it, so there were no points of intersection. Okay, thank you.